All right, so this should be a quick video. I'm under the impression that we're only in session for like another 25 minutes, so I'm going to honor the time, but we would like to take some time and go through at least one section just to kind of do a quick demo. So we're going to do the first section. This is going to be for applied statistics. Okay, let's see. So this is going to be applied statistics, chapter 1, section 1.1, an overview to statistics. Okay, I'm gonna let this stay. So it should be fairly short. I'm just gonna do it just as a demo to kind of get a feel of what you can anticipate on any given day. So some of the objectives here, so we want to look at a definition of statistics, how to distinguish between a population and a sample, and between a parameter and a statistic, how to distinguish between descriptive statistics and inferential statistics. What is data? So data consists of information coming from observations, counts, measurements, or responses. So it's just data, like pretty much raw data. Okay, these are some examples. For the sake of time, I'm just going to move forward. So what do we mean by, let me see, yeah. Can I go like this? Okay. So what is statistics? Statistics is a science of collecting, organizing, analyzing, and interpreting data in order to make a decision. Okay. So what do we mean by a population versus a sample? A population is going to be the collection of all outcomes, responses, measurements, or counts that are of interest. So a population is going to be all of the data, versus a sample is going to be a subset or part of the population. So it's going to be contained, a subset is going to be contained within the population. So for instance, in this example, it says, in a recent survey, 834 employees in the United States were asked if they thought the jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population and the sample, describe the sample data. Okay. So looking at something like this, population is going to be all. So let me pause for a moment. What do you think is the population of this information? While you think about that question, I'm going to read it one more time. It says, in a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population in the sample. So the population in this case should be all employees of the United States. So all employees of the United States, not just the 834. Okay. And then the sample should be the 834 of the all. So if we're talking about the employees of the United States, the sample should be 834 of the entire population. Okay. Let's see, how do we do? The population consists of responses of all employees of the U.S. The sample consists of the respondents of the 834 employees in the survey. The sample is a subset of the population, right? So it's going to be a subset of all the employees of the U.S. The data consists of 517 yeses and 317 nos. Okay. So when we're speaking parameter versus a statistic, a parameter is going to be a numerical description of a population, and a statistic is going to be a numerical description of a sample characteristic. Okay. So parameter, P for parameter goes with P for population. S for statistic goes with S for sample. A parameter is basically a numerical representation of a population characteristic, and a statistic is a numerical representation of a sample characteristic. Okay. So parameter goes with population, statistic goes with sample. P, P, S, S. Don't want to see the solution? No, kind of fast. That's okay. So we're asked to decide, and let me see if I click this. Okay, I see how that's going to behave. That's okay. So we're asked to decide whether each number describes a population parameter or a sample statistic. So is it a parameter or a statistic? Let's see. A survey of several hundred collegiate student athletes in the U.S. found that, hang on, let's go like this. A survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, the average time spent on athletes by student athletes is 50 hours per week. So this 50 hours, what is it referring to? Is this referring to a population or a sample? Let's see. a survey of several hundred collegiate students. So this survey was given to several hundred collegiate students. So this 50 hours is referring to the several hundred, and the several hundred is a subset of all collegiate students in the U.S. So this several hundred is a sample. So if this several hundred is a sample, that means this 50 should be a statistic. Let's see, how do we do? So it should be a statistic. Because the 50 hours a week is based on a subset of the population, it's a sample statistic. Let's try another one. Don't want to see the solution just yet. Okay. Decide whether numerical value describes, and we got about 10 or 15 minutes remaining. Decide whether numerical value describes a population parameter or a sample statistic. It says the freshman class at a university has an average SAT math score of 514 at a university. Let's see. So based on the way it's been going, this 514 is talking about the freshman class at a university. That could be a subset. You can look at that as either a subset of. Now, a lot of this is kind of open to the interpretation. My first mind is like, look, the freshman class is a subset of, it can be a subset of the school, or it can be a subset of the entire freshman class of the entire United States, right? But it definitely has a strong, let me think about it. The freshman class at the university has a, but this is talking about the entire freshman class. So it's like, do you want to look at it as the entire population of the freshman class? Or are we talking about all freshmen in this states? Only reason I'm going to say a parameter is because the last one was a sample. I'm just using a little bit of intuition. You can kind of argue this both ways. It depends on what angle it's intended to go by. I'm going to go by with a parameter though. Only reason I said parameter in this case is because the previous one was a statistic, and you're not going to do the same one again. I mean, you could, but I wasn't feeling it. So let's look at the reason behind it though. It says because this SAT score is based on the entire freshman class, it's a parameter. Okay, so it's based on the entire freshman class. Okay. Oh, maybe because like if it was say 300, like 32 freshman class, it didn't give us a number. So that means that because it didn't do that, like maybe we can say, okay, well, this is talking about the entire freshman class versus the last one, said 815 employees. That implies that it was a sample versus this one is talking about the entire freshman class. It didn't specify a subset. So that means it's a population. Let's try another one. Let's just keep going. Okay, we don't want to see the solution. We want to simulate and replicate the testing environment as much as possible. Again, we're asked to, and let's go back. I guess I can bring myself back a little bit. I think I can show that without showing the answer. Ooh, I'm gonna pull it down just a little bit. It's fine. Oh, you can see it. I can see it. I'll pull it down just a little bit more. Trying to anyway. There it is. I'll go with that. We'll just go with it. Okay. So, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. The random check of several hundred, right? So the population would be all retail stores, but this is only referring to several hundred. So there should be a sample. So then there should be a statistic. This is a sample statistic. Okay? Let's try another one. That's it. So these are some of the branches of statistics. We have descriptive statistics. It involves organizing, summarizing, and displaying data. We're actually almost done with this section. And then we have inferential statistics. It involves using sample data to draw conclusions about a population, right? Okay. All right, so let's look at this one. For each study, identify the population and the sample, then determine which part of the study represents the descriptive branch of statistics. What conclusions might be drawn from the study using inferential statistics? A study of 2560 U.S. adults found that of adults not using the internet, 23% are from households earning less than $30,000 annually shown. So the population should be all U.S. adults. The sample should be the 2560 U.S. adults that were surveyed. And then the statistic is that 23% are from a household earning less than $30,000. 23%. Let me look at the figure. Can we see this figure? Let me go like this. U.S. adults who do not use the internet, less than 30,000. So if your household earns less than 30,000, it's more than likely you don't use the internet, and that's a high percentage. The more money you make, the more likely you are who do not use the internet, the household income, not online. So there's a high percentage there that's not online. So it seems like the more money you make, the more likely you are to be online. That's what I would infer. Let's see, did I interpret that properly? So the population, okay. So it says, let's just kind of go like this. So it says, let me see the time. Okay. The population of the responses, let me see, the population consists of all U.S. adults. The sample consists of the responses of the 2560 U.S. adults in the study. The descriptive branch involves the 23% of the U.S. adults not using the internet from the 30,000. A possible inference drawn from the study is that lower income houses more than likely can't afford the internet, which matches what our inference. We said that the more money you make, the more likely you are to be on the internet, which makes sense, right? Let's see what's next. Don't want to see the solution? Okay, let's try this one. So for each study, identify the population and the sample, then determine which part is the descriptive branch and what conclusions. A study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. Let's see. So the population, I would imagine, would be all Wall Street analysts. The sample would be the 300 Wall Street analysts. And the descriptive data would be that 44% of them incorrectly forecasted high-tech earnings in a recent year. And then we might infer that that percentage of getting it wrong is actually kind of high. It's kind of close to 50%, you know. So it's like, even though for them to be a professional, you would imagine that percentage of getting it wrong would be much lower, right? So let's see, how do we do? So the solution, it says the population consists of the high-tech earnings forecast of all Wall Street analysts. The sample consists of that for the 300 Wall Street analysts in the study. The part that's the descriptive branch is going to be the percentage of the analysts who incorrectly forecasted the high was 44%. A possible inference is drawn from the study is that the stock market is difficult to forecast even for professionals. Okay, and that actually closes out this section. So what I'm going to do, I'm actually going to make this lecture available. Let me go. So I usually load it here. I put it in box, and this link is available, and I got to update that. Let me see right here. This is Applied Statistics, entire class into the notes. I need to make another folder. So those are the PowerPoint lecture slides, Applied Stats. Those are still PowerPoint lecture slides. I'm going to make another folder and make anywhere. Well, I guess it's actually already there because we didn't write anything. So I'm not going to load this one because it's already there. And I think a lot of these are, but you know what? Let me just go ahead and do this anyway, just to be consistent. So for right now, I'm going to export it here. But any kind of notes that you see me take, I'm going to make them available to you. So when this bar finishes loading, you'll be able to access any writing or anything that you saw me do. So I'll make a folder that says handwritten notes, and I'll make another folder that says PowerPoint lecture slides. Okay? And so, and that note, give me a moment. On that note, we're going to end this session here. And from one beautiful mind to another, enjoy the rest of your day. I am exhausted. I'm going to take a break. I still got to do another one to go for about another hour and a half. So I'm in the home stretch. I have been talking, when did I start? I think it was like 10 o'clock. 5 hours nonstop of talking. That's a lot. Did I start at 10? I think I started at 10. That's when I started talking. It's exhausting, man. But, you know, it is what it is. It's all good in the neighborhood. I'm thankful that I can at least have this opportunity and still have a job, and, you know, push come to shove. With the grace of God, you know, hopefully we can like increase pay and stuff like that. But anyway, we're going to end the session here. And again, from one beautiful mind to another, enjoy the rest of your day. Peace. You. This is being silly. Okay. Take care.